Assalamualaikum and hi. We are from Group G. We want to present our assignment for HVAC Electrical and Control System project. Alright, for the introduction, HVAC R. What is HVAC and R means? Okay, HVAC and R means heating, ventilation, air conditioning, and refrigeration. Okay, by controlling the temperature, humidity, and air quality indoors, we can maintain the comfortable environment. This HVAC system used in residential, commercial, and industrial. For the residential, provides thermal comfort and improve indoor air quality. For the commercial, like office, mall, and hospital, ensure a productive and safe environment. And for the industrial, it protects the sensitive equipment, control manufacturing process, and maintain comfortable workspace. Example, HVAC system that we commonly use is split air type air conditioning that we use commonly in at home and several areas. It consists two main parts: indoor unit and outdoor unit. Okay, today we want to talk about the electrical control circuit that have in the system split air type air conditioning. Okay, the objective for this project is design. For the first one is design an efficient electrical control circuit, and then apply a modern control method like thermostat control, and then evaluate performance for the thermal comfort, air quality, and energy efficiency.
My name is FARID bin KARIM. Next, I would like to tell you about the control method. The component is thermostat. It is chosen for its simplicity and suitability in residential air conditioning system. It also utilizes a thermostat to sense room temperature and control the system. Next, the electrical circuit construction. As you can see at this circuit diagram, the power supply. The system is powered by 230 volts AC across terminals L1 and L2. Power is distributed to various components like the compressor, fan motors, relays, and switch. Thermostat control. The thermostat controls the overall operation. When the thermostat calls for cooling, it closes the circuit between terminal R, that's the power, G is a fan, and Y is cooling. And indoor fan activation. Terminal G is connected to the indoor fan relay. When the thermostat is set to fan on or auto and there's a call for cooling, indoor fan relay is energized. This closes the contact in the indoor fan relay line, supplying power to the indoor fan motor. The indoor fan motor begins to rotate, circulating indoor air. Cooling circuit activation. When cooling is requested, when Y is closed, the circuit flow through the high pressure switch and low pressure switch, then to the contactor coil. This high pressure and low pressure switch act as protection to high pressure cuts off if pressure is too high, low pressure cuts off if pressure is too low. Contactor activation. If both pressure switches are close normal pressure, the contactor coil is energized. This closes the main contactor contacts, supplying 230 volts AC to first compressor and second condenser fan motor. Compressor in outdoor, fan start, the compressor start running to compress the refrigerant. Condenser fan motor also turns on to cool the condenser coil. And last, the run capacitor is assist in the startup of the compressor and fan motor. That's all from me. Thank you.
Okay, for the circuit components, we will have 6 components, which is thermostat, overload relay, compressor motor, blower fan motor, contactor, and power supply. Okay, the function of each component is thermostat. It can sense temperature and control on off. For contactor, it can switch the compressor and fan. For power supply, 230 volts with MCB protection. The function of blower fan motor, the airflow across evaporation cords. The function for overload relay, it can protect the motor. Last but not least, the function of compressor motor is it can circulates the refrigerant. For the circuit explanation, first we have power supply. Power supply, it's protected by miniature circuit breaker MCB to prevent overcurrent and short circuit. The second one is thermostat. Thermostat, it acts as the control brain of the system, sensing room temperature and deciding when to turn the system on or off. Third, we have contactor relay, CR. CR receives the signal from the thermostat and energizes the overload protection circuit. Last but not least is overload relay. Overload relay itself protects the compressor and blower fan motor from excessive current.
Evolution. The simple thermostat control acts as the control brain, maintaining thermal comfort by cycling the compressor and fan to reach and hold the desired temperature. The system's blower fan motor provides basic ventilation, contributing to indoor air quality throughout the air circulation, though advanced filtration or fresh air intake control is not explicitly included. By turning the system on and off based on room temperature, the thermostat reduces energy consumption by preventing continuous operation, primarily achieving saving throughout intermittent use. Engineering practice. System reliability and safety are ensured by the inclusion of an overload relay protecting motors from excessive current and Miniature Circuit Breaker (MCB), providing electrical safety against overheat current and short circuits. The choice of thermostat control reflects engineering practice prioritizing simplicity and cost effectiveness for residential applications, leading to a straightforward design and ease of maintenance. The control logic via the thermostat signal the contactor to energize the compressor and fan represents a fundamental and widely accepted method for residential HVAC system directly responding to the thermal load. Sustainability in implicitly supported by protective measures like the MCB and overload relay, which extend equipment life and reduce replacement frequency, and by the on-off control contribution to basic energy efficiency.
Hello everyone, my name is Joy and my metric number is B132310244. Today, I'd like to propose two strategy upgrades to our HVAC systems that can significantly improve energy efficiency, comfort, and system performance. First, upgrade to ECM motors for indoor and condenser fans. Currently, our HVAC system uses traditional PSC motor, which are fixed speed and relatively inefficient. We're recommending replacing both the indoor fan motor IFM and condenser fan motor CFM with electronical commutator motors ECMs. Why ECMs? ECMs are up to 75% more energy efficient than PSC motor. Second, integrate a smart thermostat with demand response and scheduling. Next, we propose upgrading to a Wi-Fi enabled smart thermostat that includes scheduling and demand response capabilities. Why a smart thermostat? It optimizes runtimes using occupancy sensing, learning algorithm, and weather data. First, thermal comfort. Modern control systems enable rapid response to changes in temperature and occupancy, helping maintain a consistent and comfortable indoor environment. This not only improves comfort, but also helps to reduce system wear and unnecessary energy use. Second, indoor air quality. Advanced sensors are now capable of monitoring humidity, CO2 levels, and air circulation. With automated ventilation and filtration, we ensure a supply of fresh, clean air, which is essential for health and productivity. And last, energy consumption. By integrating time scheduling, occupancy sensor, and variable speed drives, we can significantly reduce energy waste. This leads to lower utility bills and a smaller environmental footprint, win both cost and sustainability. Conclusion: smart electrical and control systems are not just optional upgrades, they are essential components of a modern, efficient, and a healthy HVAC system. Thank you.